So hello, and thank you very much for joining our web seminar. We are live from Munich. This is our very first web seminar for 2021. We are Panasonic Industry Europe, and thank you very much for joining. I'm James Weber. I'm Business Development Manager for Microelectronics Sales, and today we'll be showing you our plasma cleaner lineup. I'm here with my colleague Bernhard Oberhofer.
Good morning.
And yes, together we'll be showing you a lineup of features. First up, we will show you a video about our brand new Customer Experience Center where we are broadcasting today. It's our Panasonic campus Munich, newly constructed, over 6,000 square meters, selection of demo centers, customer experience centers, permanent exhibition. So it's designed as a permanent exhibition. So all of the year we hope to welcome our customers as soon as it's possible again. We are all looking forward. So today I'd just like to give you an overview, or now I'd like to give you an overview of what we'll be talking about today. So first up we'll show you the video on the new Customer Experience Center. Then I'll give you a presentation through PowerPoint from about our plasma cleaner lineup, its applications and how it can benefit your production. Then we'll move into a recorded demonstration from our brand new Microelectronics Demo and Application Center. So it's behind me, a brand new permanent laboratory with our machines where we can perform actual demos and show the real results. So we've done that in advance, and today we'll be showing you the before and after effects of the machine. Then after that we'll open it up to a Q&A session. So while I'm talking and while the videos are ongoing, please feel free to use the chat feature in this Microsoft Teams session. Bernhard and my colleagues in Japan will collect these questions, and then we'll go through them at the end. Hopefully, you'll get the answers you need. So that's the intention of us today. We want to make it quite an interactive session. I need around 30 to 40 minutes of your time. It's our first time doing it, so we hope not to go too long and bore you. So please stay with us, and you will enjoy it, I'm sure. So let's take a look at the video on the CXC.
The Panasonic Campus Munich will foster collaboration and synergies across different Panasonic companies, including industry, life solutions, appliances, and connected solutions.
It's a combined work and experience place where people are working day on day in their offices, the meeting rooms, the laboratories, the tech centers, combined with a very attractive customer experience center.
Now, for the first time, Factory Solutions is able to present all product lines in one location here at the campus in Munich.
The new campus offers us the opportunity to invite our customers and express our vision in systems and solutions to be a reliable partner in their projects.
The new campus is a sophisticated showroom area.
This great brand exhibition will enhance our brand awareness and visibility in Europe.
The Panasonic Campus Munich will enhance sales and position Panasonic Industry Europe as an industry leader and solution provider.
So I hope you got a good impression of our new Customer Experience Center. As I said, we are very much looking forward to being allowed to welcome you, and we would be doing that. All of Panasonic Industry Europe, not only Microelectronics, will welcome you as soon as it's possible. We're very much looking forward to it. So now I'll move into my PowerPoint presentation about our plasma cleaner lineup. You can see it now, hopefully, on the screen. So first up, I'll give you an overview of our machine lineup. On the left, you can see the PSX, the plasma cleaner we call the PSX 307. We have it either in the S or M configuration for substrate level cleaning, and at wafer level cleaning, we have the PSX 307A. So the main benefit or the main feature of Panasonic's plasma cleaning design is parallel plate type. You can see on the left and the right. The parallel plate type offers the benefit of being able to provide both a physical and chemical mechanism of cleaning. The operator installs magazines on the left side of the machine. They are inserted into the machine, cleaned and loaded into the magazines afterwards. It provides much more uniform cleaning than batch type. And the numerous benefits of parallel plate technology we'll go through in the following slides. So you can see here the possible gas combinations that Panasonic can offer, up to 5 types. So most common and frequently used is argon. Very good for removing organic and inorganic contaminants through physical bombardment effect. Also very popular is oxygen for removing contaminants and activating surface. An example of this we will see today in the upcoming video. It's also possible to use argon and hydrogen, so up to a maximum of 5% mixture for safety reasons. Very good for, well, I should say oxygen is not good for things like copper lead frames due to oxidation, so argon can be used in this case. One special example, hydrogen bonding with oxygen to form H2O. Very good application there. And fourth option is oxygen with helium. Same as oxygen, it's good for surface activation, but the addition of helium helps the oxygen atoms, as you can see in this example, to get underneath the chip. Very good for a capillary underfill. And finally, if you are using adhesives or chemicals that involve silicon, argon and CF4 is very effective at removing these chemicals because it bonds with to form SiF4, which is a volatile chemical. So we talk about how plasma cleaning can improve your quality. The main application is conventional packaging, so for example, improving molding, underfill, wire bonding ability. But there are other applications, for example, SMT processes, same kind of area, molding and underfill, and also the newly opening area of wafer level cleaning. So as I mentioned, the PSX 307A is especially good. We will show you in the further slides. So we have 5 cases that we want to talk about how plasma cleaning can be applied to your processes and improve your production. Most common application is case number 1. We have poor bonding quality and stability on gold pad. Plasma cleaning using argon can remove nickel diffusion compounds that come up to the surface of the gold pad, which improves bonding strength and achieves bonding stability. So you can see on the right side the presence of nickel. After plasma cleaning, this is completely gone. So we are able to prove this for you with our measurement equipment in Japan. Case number 2, similar application, but with a different area. Poor gold-to-gold interconnect bondability. For example, bonding, wire bonding or thermosonic bonding, as we say, flip chip bonding. We remove the contaminants from the bump surface and of the gold pad substrate. So you can see in this diagram, after plasma treatment, up to 3 times higher remaining bump rate if a shear test is performed. Case number 3 is improving molding adhesive ability. So Due to lead-free and RoHS compliance matters, sometimes poor mold adhesive ability is achieved. So one way to improve this is to modify the surface by changing or improving the wettability. You can see here before and after plasma cleaning, we are able to achieve double the adhesive ability after performing plasma cleaning. Case number 4, improving the capillary underfill process. So the issue can be a difficulty of underfill process for big size and high pin count flip chip packages. So as we mentioned before, the use of oxygen or oxygen with helium can really improve to get the improve the wettability so that underfill goes under the chip much better. Underfill time can be reduced by 40% and very high quality and uniform underfill process can be achieved. And the last case we present to you today is de-smear process after laser drilling. The issue is we need to improve bonding quality with TMV package on package bonding. So argon plasma is used to remove smear residue after laser drilling. Plasma process de-smears laser vias and improves POP bondability. So I'd like to show you the plasma cleaner PSX307 main features. This is a lineup of our S and M type. The main difference between the two is the chamber size. So you can see in the second row the substrate size, S slightly smaller and M slightly larger. The transfer system, the S-type can handle up to 3 lanes of substrates with a magazine changer, and the M-type 2 lanes. Both from 100 to 600 watts RF power, and at the bottom you can also see the varying etching rates for gold and photoresist. One of the 2 main features of our machine is the plasma monitor. So its main purpose is to detect damaging discharges before they occur. This is a patented Panasonic technology. We will talk about it in the video coming up. I will show you it, its location inside the machine, and talk a little bit about its features. So yes, the main purpose is to avoid abnormal discharges, and as an option, we can provide a log in the machine. The second main feature of our plasma cleaner is lifted substrate, lifting transfer unit. It's especially good for thin or bowed substrates, as you can see, or substrates with 3 dimensions underneath. So the substrates come in lifted, they're lowered down, then the plasma cleaning is performed, then it's raised up and loaded into the magazine. So especially good for thin and bowed substrates, and if you have 3-dimensional components underneath the substrate. This is a schematic of the transfer sequence. So on the left we have the magazine fully loaded with uncleaned substrates. These are pushed into the chamber. They're lowered down, the chamber is closed, plasma cleaning is performed, then it's opened, and these are then pushed into the empty magazine on the other side of the machine. So we can show you this in the video coming up. The machine is a lab machine, so we don't have loader unloader, but this is very easy to add or remove. So this is our PSX307A for wafer level cleaning. So the trend is, of course, smaller and thinner devices are driving more and more wafer level processes. These are causing issues such as RDL detach, resin detach, ball detach, dirty surface after dicing. So it's becoming increasingly important to clean this. Our plasma cleaner 307A can perform this. So similar applications and similar benefits. Before wire bonding, solder bump improvement, cleaning the surface of the solder bump. Again, before flip chip for gold to gold connect, and also improving the surface of the bump after mold or glue sheet. So some examples here, removing the resin residue on bumps after wafer molding. You can see after the molding or glue sheet is applied, there's residue on the top. You can see top layers photo, how that looks. And then underneath, after the plasma cleaning has been performed. Likewise, when laser vias are drilled, you can see the photos on the top, epoxy resin or polyamide resin residue. After plasma cleaning, this can be cleaned up quite nicely. This is the information about the PSX307A chamber design. So it's quite larger than the M and S chambers, as you can see on the top left. It's large enough to handle up to a 12-inch wafer with a either bare wafer or wafer on a ring. Alternatively, we can provide a tray with up to 4 6-inch wafers, 2 transfer lane JEDEC tray, 3 transfer lane substrates, or 4 transfer lane substrates, so down to 77.5 millimeter wide, which is the current standard for memory. So when you're dealing with wafers, either bare or on dicing frame, you need to also handle this with a special handling robot. So we can integrate that with third-party vendors so that these wafers, either bare or on frame, are loaded into the plasma cleaner and unloaded. Alternatively, as you can see on the right-hand side, substrate level cleaning is also possible, either with the use of traverser or the previously explained magazine-to-magazine concept. This is a schematic of the PSX307A, how it looks in the factory. So we have on the right-hand side the blue PSX307A, and then coupled up to it the EFEM with the handling robot, so that it's a totally enclosed package. You basically just load the magazine and push start, and it will clean all the wafers in there. One thing I should mention, these machines, just to get a feeling for the size, you'll see in the video, about the size, about the height of a person. So last section of the presentation, I'd like to talk about our demo center in Osaka, which we have in addition to our demo center here in Munich. We have the PSX307S machine and the PSX307A. So all of your demo needs we are able to fulfill. But most importantly, we want to prove our machine works. So we have a whole range of analysis equipment to demonstrate that we are achieving what we say. So XPS to detect the surface, or to measure the surface before and after. What components were there before the cleaning and what components there after the cleaning. SEM to get a good picture of the surface of your material to be cleaned. We also have XRF for measuring, for example, thickness of gold before and after, and also nanospec in case we have to measure the thickness of photoresist before and after. Finally, this is the water contact angle measurement equipment. So we have this in Munich as well. We'll show you in the video coming up. Basically, how the surface activation is before plasma cleaning and after plasma cleaning. And we, of course, provide the measurements from this machine. So that was my presentation, and I hope you enjoyed it and it wasn't too technical, or I didn't skip too fast. Again, if you have any questions, please feel free to put them in the chat. I'd like to remind you again, we are standing by now to collect the questions. And we will now show you the video we've pre-recorded in our demo center. It's Bernhard operating and using the machine. So please watch. Put your questions in the chat, and we're very glad to answer them afterwards when we move into the Q&A section. So let's take a look at the video.
Welcome to Panasonic Campus Munich, to Microelectronics Demo and Application Center. We promote here our flip chip bonders, die bonders, plasma cleaner and plasma dicing equipment. We have here analytics equipment for cross sections, drop angle measurements, plenty of microscopes, shear testers. And my name is Bernhard Oberhofer, and I will guide you through the application which we want to show you today. Now we are standing in front of the plasma cleaner PSX 307. I would like to explain you some functions the machine has. So the machine is available with different chamber sizes. For example, 3 liters and 4 liter. Difference is the plasma density is higher on the 3 liter chamber versus the 4 liter chamber. The machine can be equipped and functions with up to 2 different gases, where normally we use argon and oxygen. Other gas mixtures are also available optional. The machine is also available for different transport variations, where our current machine is equipped without any transport system. So you will see today's actions all manually, but the machine can be delivered with full inline capability or magazine to magazine transportation. Before showing you the tests, the machine has been calibrated in vacuum leakage, in stability of gas flow and stability of RF signal to activate the gases to a plasma. After I have showed you the specifications of the plasma cleaner in front of it, we are now in the analytics corner, and we have here a drop angle measurement equipment with 2 syringes where we use pure water and diiodomethylene. With these 2 liquids, we will calculate the drop angles and finally the surface energy. To start, I will utilize a fresh substrate without any plasma treatment and check the angles. I generate a droplet of water, transfer it to the substrate, and the system measures the angle 10 times and saves it in the database. Here they are. As a next step, we use another location and transfer the liquid, the second liquid. Same thing we do here. And measure it as well 10 times. Done now, and what we see is that we have an angle of about 80 degrees with water and about 30 degrees with diiodomethane. After having the values from before plasma, we would like to do the plasma cleaning and come back after this. Before we start with our today's surface modification, I would like to check if the machine is well calibrated. Therefore, we have under maintenance a matching tank function which would give us some good picture if the machine is calibrated well. whereas I can explain you in parallel the functions. Here we can see our recipe, which I just prepared before, where we have the two gases connected to the machine, argon and oxygen. For surface treatment, I have decided for 100 milliliter of oxygen per minute. Another recipe parameter is the degree of vacuum which we want to generate before we start the gas flow. I set to 20 Pascal. And the RF power with which we activate the gas to generate a real plasma. With 20 seconds programmed here is the duration of the whole plasma treatment, and at 70 Pascal we ignite the plasma after we have reached a stabilized pressure when the gas flow has started. Let's do this by pressing the start button. Chamber closes and the various parameters of the plasma cleaner recorded are shown here in a nice graph. What you will see is that the orange line will represent the vacuum, so it comes down to the value of 20 as programmed in the recipe. It goes up when the white line is added, which represents the gas flow has started. Then it comes down again, and here the yellow one has started the RF signal to activate the real plasma in the chamber. After the 20 seconds have elapsed, the RF power will be switched off and the chamber will open. There are some other parameters shown here in the graph, and the outcome looks good to me that we are ready now to proceed with the real cleaning of the substrate for today. Here we are at the full manual menu. I put a substrate which we want to treat into the chamber. I place it on the bottom electrode and close the chamber. This is a recipe we know already, and this is what we wanted to start. By the way, you also can program a second step, just in case it would be necessary to have two different gases followed by each other to improve your individual process. Let me start the cleaning. Chamber closes, shown by the position of the valve. The evacuation has started. The pump is continuously evacuating the chamber. The vacuum gauge has opened and the pressure inside the chamber is shown. It will be pumped down to 20. Then you will see that the oxygen gas will open. Now, after coming down again with the pressure to 70 Pascal, the RF will start and activate the plasma in the chamber. And then we have to wait until the time has elapsed. Our setting was 20 seconds. While the plasma is ongoing, we have a plasma monitoring sensor which is making sure that the plasma has really ignited in the beginning, and it also ensures during the whole plasma process that there is no abnormal discharge during the process, which ensures you quality and to your product. Meanwhile, the process has ended and the chamber is open again. I need to manually open my manual system and have the clean substrate. And with this, I can go now back to the drop angle system. Back from cleaning with freshly treated substrates, we have to perform the measurements again. Another drop of water as a first measurement onto the surface, transferred to the substrate, and start. What you can see in the picture already, that the angle has already lowered a lot. This is the purpose what we wanted to have. The measurement should have been done 10 measurements and we achieved 21 in average. Second thing is that we also have to perform our second liquid, diodomethylene. Creating droplet, transfer to surface, and starting the measurement. Started making the graph and having a result after 10 measurements of 17 degrees in average. That's exactly what we wanted to see, that our plasma cleaner is lowering the angles and generates a higher surface energy to improve your wettability of substrates. For example, underfill of BGAs or flip chips, for example. Yeah, later on we will show you as a stand picture the results of the measurement showing parallel together. Today we have learned a lot about improving the wettability on PCBs. We have seen low angles after plasma cleaning with our PSX 307 and increased surface energy. Not just wettability is an option what we can improve, also with our argon plasma we can improve wire bondability, which would increase your shear strength. We would be happy to welcome you with your own samples here in our lab to show you our capabilities. Thank you very much.
So welcome back. I hope that video gave you a very good overview of the practical applications of our machine and how it's operated. As I mentioned, please get in touch. It's our pleasure to organize such a demo for you. We will collect all of your information in advance, make a demo plan, and after we receive your material, we can make a plan to book a slot in our demo center. And you can either come and visit us and watch the results happen, or if it's still not possible or you're too far away, we can, of course, perform this with electronic means and give you a report afterwards. So please get in touch with me, and it would be a pleasure to organize that for you. So now, the last part of our web seminar today, we'd like to open up to a Q&A session. Bernhard, you've been collecting questions while I've been talking and while we've been showing the video. Anything you can mention that came up as a common question?
Yes, indeed. We have, while the video was running, we have had plenty of questions coming in, so quite a lot of interest shown. So what I would say, many people asked about maintenance. What I can say is the machine is easy to maintain. Mm-hmm. There's not much of active moving axis, so not much to take care on that side. The only thing, keep your vacuum pump in good shape and try to keep the chamber inner shielding in a good condition. So in a regular interval, 3 to 6 months, you have to take them out, put them to sandblasting and put them back. So that's the major maintenance.
Quite simple maintenance to plan, as long as it's scheduled regularly.
Yes,
no issue.
And also easy to perform from any maintenance stuff.
Okay. So another common question I get from customers mainly is how long do the machines last?
Yeah, typically we have customers which still run the machines for more than 20 years.
Okay.
So
Yeah,
they are really happy with the lifetime.
As long as they are performing the maintenance in the right schedule, I guess should be no problem, right?
True.
Yeah. One question I also get commonly from customers is, and as we saw in the video, the plasma monitor. Could you tell me a little more detail how that works?
Yes, also such questions I have seen in the chat coming in.
Okay.
So the plasma monitor works as detecting the impedance inside the plasma.
Mm-hmm.
And right before the arcing occurs, so the machine can shut down the RF signal to power down the plasma before any damage would occur to your substrates. So it would also allow to follow the plasma happened to all your substrates, yes or no, which is the traceability system to that machine as well, to keep quality to your products.
Okay, very good. Do you know how many machines we have installed worldwide?
According to my last information, more than 1,500 sets we have installed worldwide, not just in Europe. It would be a dream, but we have
Not yet.
We have them worldwide, including the predecessor models as the current ones.
Okay. Any other questions you've received?
Questions which came in also were about gas variations, but you also mentioned this in your PowerPoint pretty precisely. So argon and oxygen are the standard gases. So the machine is equipped with a mass flow controller for argon and or oxygen, and you can use it also for various other gas mixtures with some factor to adapt the correct gas.
So I can have up to two of those 5 connected, right?
That's
So
correct.
what if I want to change them?
Not a problem at all. So with a factor, you can adjust the different gas. So you still keep the oxygen mass flow controller, for example, and you connect the oxygen helium gas mixture from one bottle or your supply tube. And with a factor, you can adapt the correct gas.
Okay.
The only difference is if you would use CF4, there are several precautions inside the machine which are necessary for safety reasons, where the machine is exclusively built for this CF4 functionality.
Okay. Yes. I can imagine the formation of HF. We're coming up now on 40 minutes. Probably should come to a conclusion. Any other questions you'd like to cover at the moment, or do you think it's? Let's have a look at the chat.
Yeah.
Okay.
I would say there are some questions which we would answer later.
Yes. All right. Yes. As we mentioned, we can definitely follow up with you afterwards. We'd like to, thank you for joining us today. As I said, this stream will be available online after we're finished. So please, if you have any questions, the email will be on the screen, as you can see underneath. My name is James, so please feel free to contact, and we will definitely follow up with you. And with that, I would like to say again, thank you very much for joining us, and we will be happy to welcome you to the next web seminar coming up this year.